Hello, today we'll be taking a look at Geomagic Qualified Probe with use of the microscribe digitizing arm. So first things first, when we're using Geomagic Qualified Probe, we want to import our CAD model, which I have here sitting on my screen already. And then we will want to make sure we have our microscribe digitizer plugin set up. So we'll go to the Start menu, Options, and then we will go to Digitizers. Make sure that the hard probing plugin is microscribe version 1.0. Press OK and we're ready to begin. We'll start by using the Capture tab, and or for specific Geomagic Qualified Probe users it will be under the Alignment tab, but we'll be using the iterative alignment. What this allows us to do is to create target points on our CAD model that we can reference on our actual object that we have sitting on our desk to align this part. So we'll simply start by creating a few targets. Place one here, one here, one here. Go off to the side. Place a few targets. Go around back. Place a few. And what we want to do when we create these targets is we want to make sure that we have a good reference plane and then good driving points that will allow this CAD model to fully align to the actual part. So we'll take just a few more points and then we'll go ahead and probe them too. So to probe the points, we'll press Probe Points, and you can see it brings us down onto target 1, which is the first target we created, and we will go ahead and take a point. Now for the first 3 targets, we'll have to just get close to where we put them on the CAD model, and that will give it a basic alignment. Once we do that, you'll see now it brings a probe into place that we can use to get close to the part, and you can see it lights up green when we're actually within the target specification for tolerance. And then we'll come in here, take a few more points. Take a few more points. And we'll also note that this procedure will fail the first time, just because there's no way that we can, unless you get the first 3 points absolutely perfect. So just keep that in mind when we're doing this. So it says it failed. We want to do these points again, which is fine. Target 1, target 2, target 3, target 4, target 7, target 8, and now we are fully aligned. So now that we're fully aligned, we can go ahead and press OK and start taking a look at our model. So we have a few different options. We have our real-time deviation that we can use to look at the model, which is just a real-time go no-go gauge. You can see when we come down onto the part, it gives us our tolerance, and it says that we're good to go on this surface. If we come off of the part, you can see that that's obviously a no-go. So this is an easy way to just come in and check and see if things are where they need to be. So we can see that we're out a few thousandths on this bore. However, on this surface, we're also a little out as we go off to the right of the part. And as we move to the left, we come back into tolerance. So we can see that there's a little bit of warp going on as we get further and further to the right of the part. So say we want to further analyze that information. Well, what we'll do is come in and use probe compare, and then use the probe compare to first set up our tolerances. So let's say our tolerance is 7 thou for our nominal, and then for our critical numbers we'll run that out to 20 thou. Alright, and then we will start probing. Come in here, and now we just start taking points on the part. So we'll start getting a color map of the particular pieces and parts of the model. And if we just take these points, you can see very quickly how we can start to understand the slope that's going on here. Okay, so we will press the top button for the microscribe to exit out of this procedure, and you can see all of our icons lighted up again. And now we can look and see that there's a nice color map going across the part, and we can see the sloping that's occurring on this object. So now we'll go ahead and press OK. And then we will come in and start probing some features. So we have quite a few features that we can probe. Let's start off by just probing some cylinders. So let's come in and understand a few cylinders. Alright, so we will come in to our cylinder and start taking points along this cylinder. We want to come all the way up across the top and all the way across the bottom. And then once we're done, we will press the top button to create that cylinder, which we can see is actually offset from our CAD model, which is because I shifted this microscribe digitizer just ever so slightly in order to give us some deviation to work with, hence the reason why we're seeing slopes in the part and things like that. That allows us to have a little bit better idea of what we can do with this CAD package. So you can see, we can see the offset. We can also note the diameter difference between the two cylinders. Okay, so now we'll go ahead and probe the next cylinder. So we'll go ahead and do that now. Alright, so we can see that difference between the two cylinders. So say we want to further analyze cylinder 1 against cylinder 2. Well, what we'll do is go to Analysis, Features, my apologies. First off, we'll want to go ahead and exit the procedure by pressing the top button on the microscribe. That will allow us to come in and do our analysis. So we'll go in and create 3D dimensions. Hide this work plane, and we'll just go ahead and do some point-to-point comparisons from cylinder 1 and cylinder 2. So by selecting anywhere on the cylinders, it automatically drives to the center point, and then by selecting an area out in space, we get that distance. So we have a view plane distance we can look at, our three-dimensional distance that we can also look at, and then what is most important is our distances in relationship to the CAD model itself. We can see that by looking at the deviation to X, the deviation in Y, which will not be as important for this part, and also the deviation in Z. So linearly we can see how far they're off, as well as we can compare the distance from cylinder to cylinder in X. And then by pressing Next, we can move on to any other features, and you can see we have distance in parallel. We can also check angularity between two planes and things of that nature. So we'll go ahead and press OK, and let's look at creating a plane and what we can do with this plane. So inside of our capture function, we have the ability to create cylinders and lines also, but we have this plane function. So let's go ahead and create two planes. And say we want to understand the corner of a part. Well, this corner can be quite difficult to understand sometimes with a digitizing arm, simply because it's very difficult to get perfectly on the edge or corner of that part. What we can do with these planes is simply create one plane, create another plane, and then come in and look at the intersection of these two planes. The way we do that, and with the intersection of these two planes, we can create a line. So again, we press the top button on the hand switch for the microscribe to exit out of the function, and then for lines we'll select two planes, plane 1 as plane 1, and then plane 2 as plane 2, or we can do vice versa, and then press apply, and you can see it creates a line directly where these two planes intersect, giving us our corner of our object. This gives us a much more accurate way to create these corner lines, and we can drive that throughout the whole part and then measure these corners from one point to another in X, Y, and also Z to get our full understanding of what's going on with our part. These are just a few of the tools that we can use in Geomagic Qualify Probe. This will hopefully help you get started in using Qualify Probe. I would experiment with different pieces and parts. Also, one more thing to note is we need to go into plugin options when you get started and go to tip options and make sure we set this diameter to 0.003 for the default MLX tip, or for the G series arms we'll just leave that at 0. So that was the reasoning behind the cylinder difference in this part. When we had the cylinder sizing was slightly smaller than it should have, I'm using a M series arm that I didn't enter the diameter. That also accounted for a little bit of that angularity and some of the tolerance issues that we were seeing. So if you run into that, that's what's going on there. So for an M series arm, it's 0.003, and that will get you your default tip size. Then you just press OK, and then you are good to go. So I would continue playing around with Qualify Probe. You can do probe sections, probe points, and then use those to do comparisons in many different ways. So we'll come out with future videos regarding those different methods that we can use. But for now, this is a great getting started video for Geomagic Qualify Probe. If you have any further questions, feel free to contact us either on our website at www.geomeasure3d.com or by phone at 434-946-9125. Thank you and have a great day.